Hello everybody, welcome back to Arduino for Amateurs. This is episode number 23. We're going to be talking about dot matrix displays. As always, my name is Matt Gracie. I'm a hacker from Buffalo, New York. I'm a member of the BitHaven Hackerspace. And what I'm talking about in this video is scrolling stock ticker style dot matrix displays. I'm sure you've seen them. They have them on vending machines and lotto machines and public signage. And what we're going to talk about is how we interface an Arduino with one of these multiplex dot matrix displays. This whole project came up because of a conversation I had with Shigi at the Hackerspace. He wanted to have some scrolling signage in the exterior windows so that we could advertise the Hackerspace out to the parking lots behind the building. And I said, oh, cool, sure, I've seen those on Amazon. I'll order one. So I ordered one. And physically, it's much smaller than I thought it would be. I guess I need to pay more attention when I order things. But getting it interfaced with an Arduino and playing around with it was still kind of an interesting project. So I wanted to share that with y'all. Before I continue, I just want to give thanks to the folks at lastminuteengineers.com. This article in particular, interfacing Max 7219 LED dot matrix displays with Arduino, was super helpful for me, and I actually used a little bit of your example code in the example that we're going to see later in this video. So thanks again. Be sure to check out their site if you're interested in Arduino stuff. So this is the unit that I ordered. It is, as you can see, an 8-in-1 display module. So there are 8 individual 8x8 matrices here. 1, 2, 3, 4, 5, 6, 7, 8. Each of these is 8x8. So as you know from multiplication, that means each of these has 64 LEDs in it. Now, early in our video series, when we were turning on and off individual LEDs, we were doing it with 1 wire per LED. So you may be asking yourself, does this mean that I need 64 control wires for each one of these modules? Well, obviously that would become very unwieldy. Even if you have one of those Arduino Megas, there's not enough output to do that. The way these are controlled is through a multiplexing chip called the Max 7219, which is why it has that right in the item description. That allows us to control all of these 64 LEDs in each module and all of these 8 modules, so a total of 512 LEDs, using only a few wires, which is pretty cool. So that's what we're going to do in this video. We're going to wire this up and show you how all that works. Now, as you can see from this Amazon, I'm pointing at the screen like you can see me. As you can see from this Amazon purchase screen, there are a few different form factors that you can buy here. So this is 8-in-1. We've got 8 of these 8x8 matrices all connected to the same circuit board underneath. Then we have this version, which is 3 sets of 4, so 3 separate circuit boards, each of which has 4. Or if you want, you can buy them individually. This is 10 pieces, each an individual matrix with its own circuit board underneath. What is the difference, you ask? Well, they're all programmed in the same way, and they all contain the same logic. But if you buy one of these larger units, all of the modules are wired together automatically for you. What do I mean by that? Well, this is the underside, again from the Amazon page, this is the underside of one of those single matrix modules. So you can see we've got 5 through holes on each side, VCC and ground, so power and ground, data in on one side, data out on the other, and then CS and CLK. Those are chip select and clock. We'll talk more about what those mean in a minute. But basically, each of these modules has an input side where the data in is and an output side where data out is. So if you want to wire up 4 of them in sequence, you can wire up 4 of the individual ones here using jumpers or DuPont wires or whatever you want to use, or you can just buy one that's already 4 of the units all connected together. Similarly, if you want 8 in a row, you can buy the big candy bar version like I did, or you can buy 8 of the individual ones and wire them up. And you can do the same thing with the larger ones. If I wanted 16 modules, I could do that. I could either buy 2 of the 8s, or 4 of the 4s, or 16 of the individual ones. I don't need to tell you how division works. And then wire them up individually. The number of modules is something that we specify in the code, and it's smart enough to be able to translate on the fly. As long as our hardware matches what we're putting in the code, it should work fine. This is the underside of my 8 matrix unit. I apologize, it's a little blurry. My phone didn't take a great picture here. But as you can see, it's very similar. We've got the 5 through holes on either side of each individual module, but you'll notice that there are already traces here on the circuit board connecting this first module to the next one, right? So if I connect data in here on this pin, that is connected over here to data out, and then data out is connected to data in on the next one. So I don't have to manually solder those together. I don't have to put in jumpers or headers or anything. They're all already set up for me, all ready to go, right? So this is logically the same as 8 of those individual units. It's just all in one circuit board for convenience's sake. It makes it a little bit easier for me when I'm laying out the circuit. I only have to deal with one set of connections. And these are a little finicky, so that's probably for the best. Now, the protocol that we're going to use to talk to these devices is called SPI, or Serial Peripheral Interface. Earlier in this video series, we talked about I2C devices. You may remember that. We talked about I2C clocks and temperature sensors and humidity sensors and LCD displays, right? And those were a 2-wire device. There was basically a serial message wire and a serial clock wire, and that was it. The devices had their own individual addresses, right? But those were set in hardware, generally speaking, or you could adjust them with jumpers, but they were still not set in the code. So those 2 wires were all that you needed. In this case, SPI, also an old specification, this one dates back to the 1980s, is a 4-wire serial protocol, right? So instead of having just 2 wires like I2C, we have to connect 4 wires back to our Arduino in order to have full SPI functionality. In this particular case, we only need 3, and we'll talk about why that is now. So there are 4 specific communication lines in SPI that we're going to use. The first one is the clock. Like all serial protocols, we need to make sure that everything in the circuit is processing in lockstep, so the controller sends out a serial clock signal just to make sure that all of the minion devices, all of the subsidiary devices, are processing things at the same time and everything is in sync. So that's one wire that we need. The next one is COPI, or Controller Out Peripheral In. So that is output from our Arduino. We're sending data from the Arduino out into our SPI device. So that is the one that we're going to use in this example for this dot matrix display, because we're sending the messages or whatever that we want to display out. We're not bringing anything back in. This is not a sensor. This is not anything that we need to read. We're just sending stuff out. The next, CIPO, Controller In Peripheral Out, that's just the opposite. That is output from our devices to the Arduino. Something that is useful in some configurations, I'm sure, but not something that we're going to need to use today, so we don't have that wire connected to anything. And then finally, chip select, right? So this is a way for the Arduino to talk to different devices. Just like the I2C devices have their own hardware addresses, we can use chip select in software to designate which device the Arduino is going to talk to, right? So in this case, we have 8 separate devices because we have 8 of these little 8x8 matrices. Each one of those is its own device, so chip select is used to tell the Arduino which one it's talking to at a particular time. Now you may remember this pinout from earlier videos. This is all of the pins on your Arduino Uno. Omega looks pretty similar. Different devices may have different pinouts. You can look them up on the Arduino website. We're using an Uno R2, so this is the one that I'm talking about here. We are going to connect our device to digital port pins 10 through 13, because as you can see, those digital pins are designated as SPI pins. So pin 13 is our clock, pin 12 is output, pin 11 is input, and pin 10 is our select. You are not technically required to use these pins. You can really use any digital pin on the Arduino to control SPI devices. The difference is that if you use these pins have hardware acceleration built into the platform, so it will be much more efficient and put much less load on the CPU if you're using these SPI designated digital pins as opposed to sort of bit banging out through some other pin in software. We're not talking about a super high powered platform here. Arduinos are pretty low overhead. So if you can, you probably want to use these hardware pins in order to do it. All right. So what are we going to do? Well, if we go back here, you'll see here's our pin. We're going to connect our power to this first pin here, VCC. We're going to connect our ground to this second pin. We're going to connect data in to this third pin. We're going to connect our select to this pin. We're going to connect our clock to this pin. And if we go down here, you see in the corner of the screen here, I've got my document camera. See, I'm waving to you. That is going to show you where everything is. So we've got our external power supply, the one that we talked about in the last video, that is connected to this little breadboard here. I've got power going into it from a USB hub. That is powering these rails, and then these rails have a power lead and a ground lead. These are going down here into my LED, my dot matrix display. Then up here on the Arduino itself, you'll see I've got DuPont wires plugged into 10, 11, and 13. Right, that's my my data, my cable or my chip select, and my clock. Those are then connected to the appropriate pins on the underside of my dot matrix display. So a total of 5 pins, 2 of which are power and ground, so those really don't count. So a total of 3 pins, really, to control 512 individual LEDs. That's pretty awesome. All right, so what does the code look like to do all this? Let me skip away from my slides for a moment. And you'll see here, this is just a little bit of test codes. This is very simple. First, we have to include the required libraries. So the library that we're using to control this display is called Parola, P-A-R-O-L-A. So I've already imported that library, but if I needed to search for it again, I could just go to Libraries, Parola, and it's right here, MD Parola by Magic Designs. I'm running version 3.7.5. I've already imported that. When you import that library, make sure you import all the dependencies because it also requires this Max72 library. This is the one for the particular multiplexer chip that's built into these displays, and the SPI library, right? This is just a generic SPI protocol library for anything that's using SPI. These are particular to these dot matrix displays. So we import all of our necessary libraries. Then we define our hardware type. In this case, our hardware type is FC16. That is just the name for this class of hardware, the way this is constructed. There are a couple of other generic types, but this is the one that we're using. If you want more documentation on that, again, that Last Minute Engineers site is really good. That lists a couple of other types of the hardware. Max devices is 8 because we have 8 of these matrices. Our chip select pin is pin number 10. That's the hardware chip select, so that's the one that we're going to use. And then we instantiate a new device. So we instantiate a device, we're going to call it My Display. We're going to create an object of type MD Parola with hardware type, that is FC16, CS pin 10, max device is 8. So we're telling it this is the kind of hardware, this is how many of those matrices there are, this is what pin we're using to select which matrix I'm talking to. If I had more of these wired together, that would be simple as could be. I just increase the number of max devices and it prints across more of them. Very straightforward. All right, our setup, we do a begin, we do a set intensity. In this case, we're setting the intensity pretty much as low as possible, and it's still pretty darn bright. These things are impressively bright. They're also a big power draw, which is one of the reasons why I'm using an external power supply instead of pumping everything through my Arduino. Then we clear the display, and our loop is very simple. We're going to set the text alignment to the left, that is, start printing on the far left side of the matrix. We're going to print Arduino with spaces and an exclamation point. Pause for 2 seconds, clear the display, pause for 2 seconds, go back to the top of the loop. So this is not intended to be an exhaustive demonstration of everything this display can do. This is just a really, really simple example so that you can see what it looks like and see what the code looks like to turn it on, and we can make sure all of our wiring and everything's correct. So I've got my power supply plugged in. I'm going to plug in my Arduino. Okay. Sorry, the camera's moving a little bit. I'm just going to tie it on my desk. And I turn on the power supply. See how bright that is. I reset my Arduino. And there we go. So it turns on, says Arduino, then turns off. Very cool. There's a lot of other stuff we can do. We can move the text around, we can invert it, we can scroll things, and we're going to play around with all of that in the next video. But for this one, I just wanted to kind of introduce the hardware, show you how we wire everything together, and then we'll get into some tips and tricks next time. Okay, hope you enjoyed. See you soon.